Welcome, Mindsetters, to this grade 12 session of Maths Lit. Saturday school sessions, guys. I hope you know the drill. Pens, pads, papers out. Write notes. Because right now I'm going to ask my friend, Mr. Peter here, how we're going to be doing this today.
Well, first of all, hello.
Hi,
That's
Peter.
important to start like
Always,
that, I think.
always.
I think so. And I had a great morning this morning. I really did.
That's good.
My two hockey teams played hockey. The first 11 and the second 11. Second 11 drew 2-0, or 2-all. How can you draw 2-0? Drew 2-all. And my first team, 2-0 win.
Nice.
I like winning, hey. It's like so
It's always
good.
a good feeling.
And I think these guys are going to be on a winning streak today by watching our program and seeing what we're doing. And to answer your question, what we are going to do today is we're going to go through some past papers.
All
and
right.
the first bit we're going to go through is a little bit of paper 1. We started that on Thursday, so we're going to carry on a little bit. And then halfway through the program, we're going to switch to paper 2 type questions.
All right,
So it should be a
awesome.
good session.
All right, good.
Great.
All right, so while Mr. Peter takes his way that way, guys, make sure you know the drill. Get on the page, www.facebook.com/learnextra. And guys, there's also a phone number you can call, 0861058262. It's also there on the page. So guys, feel free to call us. Let us know what you're thinking. If you're lost anywhere, if you need help, guys, also post on the page. And guys, I was loving from the previous session the way you guys just kept on helping each other, because that's why it's there. So guys, keep on doing it because I was loving it. Awesome stuff. And right now, I'm going to shut up because Mr. Peter has a show to do. Peter, take it away.
Right, great. And before I do start, what I want to say is, I think what we're doing is if viewers out there have a question or a problem they'd like to pose to us, if you phone in then and ask us a question, not only will we try and help you, but for phoning in, we've got a little something, and I think you've got to tell them about that.
Yes, exactly. Guys, they are these awesome winter school books which you guys can get so you guys can actually study for your exams that are coming up. This is like awesome stuff. Like, Mr. Peter, I know you went through this the other day and you're like, this would help so much. You're like even considering buying it for your students as well.
Absolutely.
Yeah.
In fact, I'm going to buy one for every single one of my students because I think they're so fantastic. Lovely revision books, guys. Well worth getting hold of one. So you phone us, you give us a question, or you just phone and chat online or whatever the case may be. And for phoning in, asking a question, you could be the proud owner of one of these phenomenal books. Okay. Right, that's the end of the preamble. Let's get on with today's show. And I said we were going to start off by doing a few paper 1 questions. We started them on Thursday, and so today we're going to go through a few more. Right? Let's have a look at our first question of the day. Electricity has become a scarce resource in South Africa. As a result, the country is investigating alternative sources of generating electricity. One alternative source of generating electricity is a wind turbine using rotating blades as shown in the picture and in the diagram below. So here's the picture and the diagram, right? And it says the wind turbine is mounted on the top of a 50-meter high tower, and the length of each blade is 31 meters. Now, early on in the year, folk, I had the wonderful opportunity of going across to Belgium and across to the Netherlands. And while I was there, I noticed all these huge, white, almost windmill-type things. And they realized then that what they were is what is exactly in this question, these huge wind turbine generator-type windmill things. And what happens is they designed in such a way that they pick up any wind movement, and so they begin to rotate. And as they rotate, so they now begin to generate electricity. And Belgium, as well as, like I said, Netherlands, are busy using these things. They're very popular. And in some towns, half their electricity is generated by wind, which is phenomenal. And I think we could do learn quite a bit from that, especially if we're living on the west coast of South Africa, where it gets quite windy, doesn't it? Even down in Cape Town, it can get quite windy along both those coastlines. Imagine if we had these, how much electricity we could generate. Something well worth looking into. But let's have a look at the maths behind it. And you see, that's what I love about maths literacy, is that we're taking a real life situation. We're taking something that happens in real life, something that's actually occurring in Europe at the moment, and we're going to take it and we're going to look at a bit of mathematics behind it. That is phenomenal. Okay, so there we go. There's the wind turbine. A few facts we've got to know. First of all, from the base, in other words, from the ground, all the way to the center of our turbine, in other words, from this point all the way down here, we have got 50 meters in height. We then told as well that the length of a blade, one blade, is 31 meters. Now that's important information to know, because obviously we're going to use that when we answer some of these questions later on. Okay, so let's see our very first question. So our first question says this: what is the length of the diameter of the circle that the blades generate as they rotate? So let's have a look here again. So we know that one blade is 31 meters long. If it's 31 meters long, now if I'm the center of the turbine and this is my blade is 31 meters long. What is the whole rotation? In other words, what's the diameter, or what's the length of two of the blades? And that's straightforward, isn't it? Because we're giving you the radius, we're telling you the length of the blade, in other words, the radius is 31 meters. What's the diameter? It's going to be 62 meters. So that's straightforward, simple, easy, nothing difficult about that at all. So we're going to say that is 62 meters. Okay, let's get a pen here. There we go. 62 meters. Right, my next question. Calculate the maximum height from the ground that the tip of the blade will be if the turbine is rotating. Okay, just one little interruption again. Look here, 1 mark. It was a simple answer. Look here, 2 marks. So I know with 2 marks, it's not going to be very difficult to answer this. So what are they asking me? They're asking me how tall, or what's the maximum height one of these turbines can be from the ground to the center plus the actual length of the blade. So if we go back and we have a look at that, what we're going to see is, oops, let's just get rid of that. What we're going to see is this, that from the ground to the center is 50 meters. So from the center all the way up, and let's use a different color, from the center all the way up to the top, in other words, the length of a blade is another 31 meters. So what is the total height? Now I'm sure you can't see that yellow, so let me use a nice pink. Okay, so all the way to the top, round about 31 meters. So the total height from the ground all the way up to the top must be the 50 meters plus another 31 meters. So to answer that question, we're going to say, you know what, that's straightforward and easy. It's 50 meters plus the length of the blade, 31 meters, which gives me a total height of 81 meters. See, guys, that's high, hey? That is really, really high. And when I was in Belgium, we actually saw these things, and they stand out, and they really look awesome. They're huge and tall. Some of the people are complaining because they're saying it's actually causing a type of pollution over the wonderful fields in Belgium and things. Okay, but high things, and I think they've got a wonderful purpose. Next question. Calculate the circumference of the circle made by the blades when they rotate. We're told that circumference is equal to 2 times pi times radius. Now, gentlemen, what we've got to understand is this, that in a paper, if you are given a formula, folk, you've got to use that formula. If you ever get given a formula and you finish answering that question and you have not used the formula, chances are you've made a mistake, or the examiner has lost it a little bit. But you know what? I'd like to think it's probably going to be your mistake. So if you get given a formula, use it. So we're going to use this, and we are going to say, right, the circumference is equal to 2 times pi, and for pi we're using this 3,14 times the radius. What was the radius of the blade? In other words, what was the length of the blade? And remember, the question is, what is the circumference that's been made by the turning of the blades? Okay? And the radius will be the length of the blade. So I'm going to say times 31 meters. Now, all we do is we take out our calculator, and we're going to say, right, it's going to be 2 times 3.14 multiplied by 31 meters equals, and there's my answer, and it's going to be 1,95 times 10 squared, okay, or 10 to the power of 2. What does that mean? Let's write that down. 1,95 times 10 to the power of 2. Well, it means it's like saying 1,95 times 100. And what's 1,95 times 100? It's going to be 195. 195 what? 195 meters. Why meters? Because my radius was given to us in meters, so we're working in meters. So that's the circumference, in other words, the whole length that the blade is going to rotate around. The tip of the blade is going to move all the way around until where it started, and that distance is a whopping 195 meters. Sure. That's a long circumference, especially when you think that at school you can run 100 meters, and you know that 100 meters is pretty far. Imagine now saying that the blade is traveling around 100 meters plus nearly another 100 meters. That's a long way to go. Okay, our next question. Our next question says this. Calculate the area of the circle made by the blades when they rotate. In other words, what we've done is we've started off, we were given the radius, we were then asked to find the diameter, we were then asked to find the circumference, in other words, the distance traveled by the tip of the blade, and now we're saying this whole circle that's made by the turning of the blade, what area is that covering? And they give us a formula. They say, hey, area is equal to pi times r squared. Now, if they've given us that formula, you got to use it. Got to use it. Whatever gets put in front of you, you got to use. It's like when I was growing up, okay? My mother would put food in front of me and say, whatever in front of you, you eat it. And you eat every bit of it, young man. And so there it was, cabbage and spinach and lettuce. And it was like gross. Okay? But we had to plow our way through it. And I remember as a little kid, like sitting there for like 10 minutes thinking I can't do this. And having to sit there until I'd gone through all my food. Now, I'm the same with Maths Lit. What I'm saying to you is this. Don't you dare move away from that question until you've used all the formula in front of you. Okay? And that's what we're doing. So we're going to say, right, here's a formula. So my area is equal to pi. Instead of pi, I'm using 3,14. So I've got 3,14 multiplied by my radius squared. What was my radius again? It was 31 meters, and we're going to square it. So again, with my calculator, I'm going to say, right, we've got 3.14 times 31 meters squared equals, and we're going to land up here with an answer of 3,02 times 10 to the 3. Okay. Now, gentlemen, what I will say is this, that this whole calculator has been set up in a science mode. In other words, just before this show, we probably had biology or science or something boring like that. Biology, was
life
it?
science.
Okay, life science. And they set this calculator up to be in scientific notation, which is ugly and it's horrible. And so what we do need to do is we need to clear out our whole calculator. And I'm going to show you after the break, because we're going to take a break, I'm going to show you how we clear a calculator, which is an important thing to do before you write any exam. Because you never know if your buddy got hold of your calculator and suddenly changed the settings. You sit in an exam and you say, what's going on? Like right now, I'm doing this and saying, what's going on? We've got funny figures here. We've got to know how to change it. And I'll show you that after the break. So don't go away. Over to you, Ty.
Thank you, Peter. So guys, I cannot stress enough. Make sure you stick around after this break, because by the way, I still have to give away one of these books. So guys, keep posting. But on an important note, guys, I don't want this to just be a whole race about, yeah, I want to post because I want to get a book. Guys, the book is just a bonus. The real point is that you guys need to help each other, because it can make the biggest difference. Like, you don't understand, the biggest difference. Because that's why you guys need to help each other out. But besides that, I'm going to get off my soapbox and tell you guys, see you after this break. Welcome back, Mindsetters. I hope you had a nice little break and you made sure you went and got snacks or whatever you needed, some water, all that stuff, so you guys don't have to get up or fidget or move or do anything, because you guys need to be paying attention for this. And guys, again, please keep posting on the page, and maybe you can get one of these sent to you, because this is so awesome. It's an awesome book. I've been going through it, and it is really helpful. So guys, make sure you get posting. But for now, I'm going to hand it over back to Mr. Peter. Peter, take it away.
Right, guys, just before the break, we were actually doing a calculation, and to my horror, I realized that the calculator had been set in something called scientific notation. And so all our answers were going to be times 10 to the power of, times 10 to the power of, which is a bit of a nightmare if I'm sitting in my exam, and suddenly I start getting these weird answers. And so before the break, I said, after the break, which means now, because we've had the break, you see. So from now, what I'm going to do is I'm actually going to show you what you should do before every test, before every single exam. Because you never know if your calculator's been in your bag, the buttons have rubbed against a book or the back of the bag, okay, or against your lunchbox, whatever the case is, and by doing that, certain buttons have accidentally been pushed, and suddenly, voila, your calculator has been reset. It's the same thing with having what do you call these things, a cell phone, okay? Sometimes you've got a cell phone, you put it in your pocket, right? And you're going along, the buttons make friction with your leg, and suddenly, voila, you're phoning someone and you don't know about it at all. And the same thing can happen with your calculator. So we've got to know how to clear the calculator. And I'm glad this happened, otherwise I would never have told you this. And I always tell my classes, make sure you do this before a test, before an exam. So this is what I've got to do. I'm going to clear my entire calculator, and I want to reset it the way I would have got it when I bought it from the factory. And the way I'm going to do it is this. I'm going to push my shift button, okay? Once I've pushed my shift button, I'm going to push the number 9 because it's got CLR in yellow. Can you see the shift is in yellow? And so when I push shift, it's saying whatever button I push now, it's going to follow the yellow instruction above that number. So I push shift, I now push 9, so I'm pushing not 9 but actually clear. And it gives a question to you. It says, do you want to clear your calculator? What do you want to clear? The setup? Do you want to clear the memory, or do you want to clear everything? And that's what you're going to push. You're going to say, you know, I want to clear it all, everything. And what do I have to do if I want to clear it all? I've got to push number 3. So that's what I'm going to do. I push 3, and on my calculator it says, you really want to reset everything? And you want to say, yeah, I do, absolutely. What do I push if I want to clear everything? Well, it gives me the instruction, and it says equals. So I push equals, and it says everything's reset. Push AC button, I push AC button, and voila, my calculator is in the same position, or in the same way it was when I bought it, when I first started to use it. And that's how we want it for all our maths lit calculations. Should I run through that again? I think I should, because it's vital, hey? And if you're at home, write this down quickly and practice it on your calculator. So, first thing we do is we push shift. Once we push shift, we push 9. And it says, you want to clear it? Yes, we do. What do we want to clear? We want to clear all. We want to clear everything. I push number 3. Once I push 3, it says, are you sure you want to do this? I'm going to push equals, because my answer is yes. Now everything's reset. I push AC, and I'm ready to go again. Okay, that's fantastic. So now we can go back to the question we were doing before the break. And what was that question? Let's have a look. Area is equal to pi times r squared, and we were asked to calculate the area that was made from the rotating blades. Okay, are you looking at me? There we go. From the rotating blades, the whole area. And area is equal to pi times r squared. So now let's push this up on our calculator, and we're going to say, right, we've got 3.14 multiplied by 31 squared equals S to D, and there's my answer, 3017,54. 3017,54. Comma 54 what? Comma 54 meter squared. Why squared? Because we're dealing in area. Happy? You okay with this? Let's go on to the next one. Suppose each household requires 25 kilowatts of electricity daily. If one wind turbine produces 1,750 kilowatt hours of electricity daily, calculate how many households could be provided daily with electricity from one such turbine. Again, guys, it's not going to be difficult. Why? It's only worth 2 marks. So let's answer this question. So I know I've got 1,750 kilowatt hours of electricity. Each household, on average, on a day, uses 25 kilowatts. Okay, is that right? Yeah, there it is, 25 kilowatts. So we're going to divide it by 25 kilowatt hours. Equals, again, with our calculator, we've got 1750 divided by 25, and my answer is 70. So I know I've got 70 houses that can be supplied with electricity from one of those turbines every single day. Okay, that's quite amazing. You think of how many houses are in your street, right? And every big house can be provided, or 70 of them can be provided electricity from just the wind. Okay, so we're not plowing into the ground and digging out coal. We're not causing nuclear power stations. We're just using the wonderful nature that we have, and that's the wind just going round and round. Do you know, Ty, that overseas as well, in Holland, and Holland doesn't have very much sun, but they're actually making electricity from solar panels as well, which is really phenomenal. Okay, and I heard that if we filled up or put a whole lot of solar panels in the Sahara Desert, okay, the amount of heat that's generated in the Sahara Desert, and with a few panels that they put out there, they could actually provide the entire Europe with electricity. Now, I don't know how true that is, but that's quite a fact.
Really
and that was
handy,
told to me by someone who was quite clued up. So that's quite interesting. Hey? And that's just by using wind and electricity. All right. Let's move on. Let's try and move on. Okay, here we go. Right, our next question says this. Mr. Ndlovu uses a graph to illustrate the number of days it would take a number of workers to build a wall. So we're going to try and build a wall, and we need to know how many workers are we going to need to build the wall in a certain amount of days, right? So let's have a look at it. Now, this is a very, very strange graph, okay, in the sense that, and I hope we can see the blue line clearly. If not, then I must make it a yellow. We can sort of. Okay, let's try and make it nice and bright. Let's go pink. Okay, so here's my graph here, and I'm just going to try and redraw it there. I hope we can see that. That's kind of come out nicely. I've kind of missed the line, but we get the idea. Right, there's the graph. Now, from this graph, what we can see as well, that if one person were to build the wall by himself, it's going to take him 20 days. One person, 20 days. Now, for some reason, people battle to understand the concept that if it takes one person 20 days, how long is it going to take two people to build the wall? And so many people are quick to tell us. Do you know how many times it takes one person 20 days? How long is it going to take two people? 40. Absolutely wrong. Okay? 10 days. It's going to take half the amount of time. And yet so many matrics out there are so programmed to believe if you buy one packet of chips for 10 Rand, you're going to buy two for 20 Rand. If you've got to buy one packet of chips for 10 Rand, you're going to buy three for 30 Rand. They get so indoctrinated, as it were, into multiplying, that we now give them a question, say, if it takes you one person to build a wall and it takes him 20 days, how long will it take two? And it's so automatic, like Ty said, 40. Why? Because we just programmed into multiplying. But if we stop and we think about it logically, right? And I know Ty wasn't thinking because he was busy saying Haza to someone out there about a question. But if you stop and think about it logically, you're going to say, you know what? If it takes one person 20 days to build the wall, and I bring in another person, surely it's going to be a lot quicker. It must be. So one person takes 20 days. Two people, if they work at the same speed, it should only take them, two people should only take 10 days. Absolutely. How long would it take 4 people? Well, if it takes a one person 20 days, it's going to take 4 people 5 days. Time?
Exactly.
Cool.
I'd put up my hand with the number. See,
All right,
5.
excellent. Brilliant. Okay. So it's going to take 5 people or 4 people 5 days. There it is. Okay. How long would it take 5 people? Well, we're saying 20 divided by 5 is going to be 4. There it is over there. Okay. How long would it take 10 people? Well, 20 divided by 10 is 2. Right. That's presuming, of course, that they all work at the same speed, and presuming that they don't stop and have a big chat to their buddies, because then nothing gets done. Right. So can you understand how we're getting that graph? Right. And understand as well that the difference between 1 and 2 people working is a whopping 10. Let's have a look at this. Okay? The difference there is 10 days. However, the difference between 2 and 4 people, 2 and 4 people is going to be only a 5-day difference. The difference between 5 and 4 people is going to be only a 1-day difference. Do we understand that? Okay, only 1-day difference. Whereas here there was a 5-day difference. Whereas here there's a 10-day difference. So the biggest difference is between 1 and 2 people. And because the difference is not constant, we can't have a straight line. Remember, whenever we see a straight line, we know there's something constant going on. But in this case, there's no consistency. So our graph is going to have a bit of a curve to it. Do we understand that? Okay. Now, let's look at some of the questions. Bearing in mind this does come from a paper 1, so we're expecting some easy questions. First question. How many days would it take for the wall to be built by only 1 worker? We've answered that, haven't we? 1 worker, 20 days. How long will it take? Estimate how many days it would take for the wall to be built by only 6 workers. Right, so now we got 6 workers. Here's the point over here. It's not exactly on a line. Can we see that? Let's rub all that out. Can we see that dot's not exactly on 3 and it's not on 4? In fact, it's not quite 3.5 either. So we could say, you know, it's around about quarter, maybe 3.25 days. It's going to take 6 workers. How could we actually find the real answer? We could find the real answer by saying 20 days divided by 6 workers. Let's do that quickly. Let's say 20 divided by 6 equals, and there's my answer, hey? 3 1/3, or 3,33. So we were very close at estimating, right? And we knew we could estimate because the question said estimate. So because it said estimate, folks, I know that the examiner didn't want an exact answer. If I said, hey, it takes 3,33333 days, the examiner is going to say, you know what, this guy hasn't estimated at all. He's just taken his calculator and done it. Estimate. So we looked at the graph, looked at it and said, you know what, it lies somewhere between 3 and 3.5. I'm going to go for around about 3.25 days. And you know what, I would have got full marks for that, even though the answer was 3 1/3 days. Right. Next one. Calculate the minimum number of workers Mr. Ndlovu should employ to build the wall in exactly 5 days. So he wants to build the wall in 5 days. There's our 5 over here. So if he wants to build it in 5 days, how many workers does he need? He needs 4 workers. Okay, straightforward. Next one. How many workers will he need if he wants to complete it in exactly 8 days? Well, let's have a look. 8 days, right? Here's 8. We're going across, and we're going to hit over there. So he needs round about 2.5 workers. Now, folk, I have a problem with that answer. Okay? I can't get half a worker. So if I get an answer of 2.5 workers, what am I going to do? Am I going to make it 2 workers, or am I going to make it 3 workers? Right? Remember, we want to finish the work in 8 days. Now, if I take 2 workers, it's going to take me 10 days. If I take 3 workers, it's going to take me just under 7 days. So I would say my answer should be 3. Because if I got 3 workers, I'm going to finish it in 8 days. And you know what? I'm going to have a little bit of time left over. If I only use 2 workers, I'm only going to, even if they work their best, still going to take 10 days. Not going to finish it in those 8 days. Right. Next one. No, next one, this one. In fact, we've got another question here, an aquarium. Should we take a break now, or should we? In fact, I believe we've got somebody who had a question, who posed a question, and I think what will be a good thing is if we take a break, and in taking the break, we'll then come back, answer their question, and then get on with this question.
All right, no problem. So guys, make sure you know what to do. Stick around, because we're going to see you after this break. And remember, I still have these books to give away. See you soon. Welcome back, Mindsetters. I hope you had a nice little break. You've gotten yourself some water, hydrate yourself. Make sure that your brain is ready to do some work. Guys, have your pens and pads out and make notes, because it's so important. Because, guys, this is why we're doing this revision section, just for you guys and for those who are writing very soon. But for now, I'm going to actually hand over to Mr. Peter.
And I'm going to hand it back over to you,
Yes.
because we had a question from someone. Do you want to read that question, say who it's
Yes.
from and what the question was?
Basically, Linde Erasmus, I wanted to find out if they give you a number or total, say 1,720, if my brain decides to work today, and tells you that it's 90% of a whole amount. How do we calculate that?
Okay, so Lindsay, what your question is this, that if you get given a figure and you're told that 97% of a full amount is 1,720, what was that full amount? Okay, great question, Lindsay, and let's have a look at it, because that's important. In fact, that's tending to move on to like a paper 2 type question. Let's have a look at it. So here's what you say. 1,720 is 97%. We want to know what is 100%. In other words, what's the full amount? Well, Lindsay, what I've always said to people, and I'll say it again, it was Lindsay Erasmus, was it?
Yeah, Linde. It's
Linde.
Linde.
Okay, sorry, Linde. So what we're actually saying is this, that if I know 97%, let's always find 1%. And I always tell my students that. 1 is a fantastic number. It's a wonderful number, and a number which we should always try and get to, because it forms the basis of anything. So from 1, we can go up or we can go down, whatever the case may be. So you know that 97% is something. Let's find 1% first. Now, how did I get from 97 to 1? I divided it by 97. So what am I going to do to this weird and wonderful figure here? I'm going to do the same thing that side, aren't I? I'm also going to divide by 97. So let's do that. So it's 1720 with our calculator. We've got 1720, and we're dividing it by 97. Okay, oops, I pushed the divide twice here. Okay, divide by 97 equals, and we're going to get an answer. All right, I'm going to leave the answer as a fraction, 1720 over 97. So let's write that down. 1720 divided by 97. Now, why didn't I write out the whole number? Well, I don't want to start rounding off yet. And here's an important thing you guys must remember in your exams. When do we round off? Well, we should round off only at the end of a question. Otherwise, if we start rounding off halfway through a question, we start losing a little bit of accuracy. And if we round off again later, we lose a little more accuracy. And if we round off again later, we lose a little more accuracy. And eventually we get to the final answer, and we've lost a lot of accuracy along the way. So I'm not going to round this off. I'm going to leave it as 1720 over 97. Now what I'm wanting to do, from 1%, I want to get it to 100. How do I get that to 100? I multiplied it by 100. So 97 divided by 97 gave me 1. 1 times 100 gives me 100. So I'm going to do the exact same thing here. I'm going to say 1720 over 97 multiplied by 100. And let's see what we actually get as our answer. So we've got the 1720 over 97, multiply it by 100 equals, and now we've got our answer, okay? And our answer is this whopping number of 177319. I think I've definitely made a mistake here. Have I? I have. I know I have. Let's do that again. I'm going to say I've got 1720 over 97, or divided by 97. Let's stick to the fraction button. 1720 over 97. Then I'm going to multiply all that by 100, and I'm going to land up with an answer of 1773. Okay? 1773, and it was comma 19. I'm just going to keep it as 1773, right? Because the question would probably be, say, round to the nearest whole number. All right. Now, Lindsay, did you see how we did that? So we were given 97%. We found 1%. Once we knew what 1% was, then we could work out what 100% was. In the same way, that question could be worded in any way. We could actually say if 97% is 1,720, what is 40%? Well, then it's simple, hey? Again, we started with 97, we get it to 1, and then instead of going to 100, we get it to 40. And we multiply it by 40, and we get our answer there. All right. Lindsay, I hope that answered your question, right? And thanks for calling in and bringing it in. And I'm sure one of those books will be sent to you shortly. We'll get hold of you. We'll find your contact details and your address. So thanks for that question. Really good stuff. Do we have any other question right now?
Yes, we actually had another question that just came in, but because this was actually on another section, which is basically conversions, because I found that a lot of the students are having issues with that.
Right.
So in terms of currency conversion,
Okay.
So one of the questions was, how much is $25, for instance?
Okay, so great question. Let's have a look at it. So you go off and you see something advertised, and they say only $25, and you're like, oh, what? Well, what is $25? Is that a lot of money? Is that a little bit of money? Is that the same as 25 rand? Is it more than 25 rand? Less than? What is $25? Well, the first thing we've got to do is we've got to be able to get the exchange rate. And so the way we go ahead and get an exchange rate, you can read it in the newspapers, or you can go to any bank's website. And on the website, they'll give it to you. Do we have that there?
Yes, we do.
What
It's
do we do?
830. It's actually 840 technically.
So it's actually telling us that
8 rand.
$1 is equal to 8 rand.
39400. But we just round off.
8 rand 39. All right, cool. So we are saying that $1 is equivalent to 8 rand 39. So what's $25? Now, do you remember in the last question I said to Lindsay, let's always find 1. So if I know that $1 is equal to 8 rand 39, I can then work out what is worth $25. Now, again, how did I get that 1 to being 25? I multiplied it by 25. So what am I going to do this side? I'm also going to multiply it by 25. So I'm going to say, right, we've got 8 rand 39, 8 rand 39, and we got 25 of those things. What's it equal to? It's equal to 209 rand and 75 cents. So I've got 200, and what was it? 200 and? Oh, you're not very helpful here. Here we go. 209 Rand, 75 cents. 209 Rand,
75 cents.
75 cents. So $25 is worth a lot more than 25 Rand. Okay? Was that question from someone specific or just
No,
general?
it was a general question, because the other thing was that we're kind of trying to also look at it in terms of, for instance, if you're dealing with pounds, kind of the same process. Because if it was, for instance, 15 pounds. Say.
Okay, so same sort of thing. So if I say to you, well, which is more expensive? Here's a good question. Which is worth more, right? Let's say we've got $20 or we've got 20 pounds. And I presume we're talking with British pounds and US dollars. So which is worth more? Well, for the dollar, we've already said that $1 was worth 8 Rand 39. So $20 must be worth, and we do this on our calculator, and we say 8 Rand 39 times 20, and we get an answer now of 167 Rand 80. Just have a look at that figure on your screen, folks. It's 167,8. Now, we know we're looking for an answer in rands. As soon as we look for an answer in rands, we've got to have 2 decimal digits. So it's 167,8, no, 80. So you're saying 80 cents. You can't say it's 8, okay, of a rand. It's 80 cents. So it's 167 Rand and 80 cents. 167 Rand.
80 cents.
And 80 cents. Cool. Now, we want to know how much is 20 pounds worth. Well, before we know what 20 pounds is worth, we've got to know what 1 pound is worth. And what is the current exchange rate?
It's 12.9889.
12.9889. Okay, I'm going to say 12.99. All right. Folk, in reality, okay, currency is rounded off to 4 decimal digits. And the reason why it's rounded off to 4 decimal digits is when one country is converting millions and millions of rands or pounds or dollars into another currency, 4 decimal places is vital. It's crucial. It makes a huge difference. However, in mathematical literacy, what we tend to do is we tend to give it to you rounded to the nearest cent. Okay? And the reason we do that is because we generally work with a little bit of money. But there's nothing to stop the examiner from giving you 4 decimal places in an exam. Right? Nothing to stop them from doing that. So you've got to know how to do it. So instead of multiplying by 12,99, you'd multiply by 12,9889. 89. All right. But for our purposes today, this is what we do. So how much is 20 pounds worth? Well, if I got 1 pound worth that, I know then that 20 pounds must be worth, we got 12.99 multiplied by 20, and we now get an answer of 259 Rand 80 cents. So it's
259 Rand 80 cents.
59 Rand and 80 cents. So what's worth more? $20? Oh, in fact, we were supposed to find 25. We found 25.
No, but then
20.
you had...
We did find 25. Hey, I just wrote it wrong. Right. So $25 worth 167 Rand 80. 20 pounds is worth 259 Rand. In fact, we did.
No,
we found 20. We messed this
Yeah.
question up. Didn't we? Great. Live TV, and we just messed up the question. The question was, how much is $25 worth? All right, so let's do that. Okay, let's just pretend that doesn't exist, and let's just pretend what you saw never happened. It's all in your mind, all right? It's all in your... Right, so 25. Let's go ahead and do that. We're going to say, let's try again. Take 2. 25 times 8 Rand, what was it? 39. Hey?
Yes.
39 equals, and we get an answer of 209.75. So it's 209.75. Okay. So what's worth more? 20 pounds or $25? 20 pounds is worth a lot more. Does that help answer these
I think
questions?
so. Because then, I don't know, we have another one that come up with another actual section, which is on more working out tax and VAT. Because Suresh wanted to find out, how do we calculate 14% VAT of 230 Rand? Because she says, I know how to do it, but I get a bit confused. How will I calculate the answer?
Okay. You're going to have to say that to me slowly.
Okay, no problem.
We want to find 14%
10% VAT
yeah,
of 230 Rand.
Of 230 Rand. Okay. Well, first of all, whenever we hear the word percent, or we see the sign percentage, what's her name?
Suresh.
Suresh. So Suresh, whenever we see the percentage sign, we know we're talking about something over 100. So 14% is like saying 14 over 100, multiplied by 230 Rand. So straight on our calculator, 14%, fraction button, 14 over 100, multiplied by 230 Rand equals, and there's my answer, 32 Rand 20. So my answer is going to be 32 Rand 20 cents. Okay, does that make sense? If you wanted to take it further, so Suresh, if they wanted to say, what is their total amount you're going to pay now? Well, then what you're saying is, well, if I've got 14% and I know it's 32 Rand 20 and that's the VAT, then I've got to add it to the 230. So I'm going to say, right, I've got 230 Rand. I've got to add the VAT of 32 Rand and 20 cents, and that is going to give me an answer of 262 Rand and 20 cents with VAT. Okay? Does that help you answer your question? Suresh, I hope we have answered. Anything else out there, or are we all right?
It's up to you, because we've got probably a lot more.
Okay, well, give me another one.
Okay, Langa wanted to find out, this is now more with distance.
Okay.
He wanted to find out, how do we calculate the distance between Ermelo and Bella Vista if they are 11 centimeters on a map? Calculate the actual distance in kilometers if the scale is 1 is to 2,500,000.
Okay, great question. Really great question. Something that you could well see in a paper too. Okay, and you know what this question, who's the young man's name?
Langa.
Langa, it's a great question because it's something that a lot of grade 12s battle with, this whole concept of scales and maps and things like that. I just gave my grade 11s a question in one of their tests on something like this, and I want to tell you a little secret. A lot of them got totally confused about it. So, great question to give us. So, I measure the distance on a map. And I've got the distance and it measures out to 11 centimeters, and I want to know what is the real distance in real life between those two positions. Well, I get given a scale, and my scale says 1 is to 2,500,000. So the first thing I need to do, and I always make my students do this, and Langa, you do it as well. You know you're dealing with a map and you're dealing with real life. And you need to determine which does the one belong to. Does it belong to real life or does it belong to the map? And obviously it belongs to the map because it's a lot smaller. So I'm going to say my map to my real life. Okay. Now, just by writing those two words, somehow it puts me at ease. And somehow straight away I now know that one of those numbers are talking about what I see on my map. The other number is talking about the real distance. Okay? How far something is. Or the distance between those 2 points in real life. Okay, so we want 11 centimeters. Now, 11 centimeters, how did I get that 1 to be 11? I multiplied it by 11 centimeters. What am I going to do to this side? I'm also going to multiply it by 11 centimeters. So I'm going to say here now, I've got 2,500,000, doof doof, 1, 2, 3, multiplied by 11, and I'm going to land up with 1, 2, 3, 4, 5 noughts, 275 and 5 noughts. So it's going to be 275 and 1, 2, 3, 4, 5 noughts. Notice I've got centimeters. I'm going to have centimeters here. Now, the producer's telling me in my ear Langa that I've got to take a break. You don't go away, though, because I've got to finish this. And there's something really important I've got to tell you about scale. All right? So all you viewers out there, don't go away. We'll be back.
All right. So, guys, as Peter said, make sure you stay tuned. Langa, stick around because we still need to answer your question. And guys, keep posting. And you could be like Linde and actually have one of these books sent to you. So guys, keep sending in those questions. But for now, I'm actually going to send you on a break. We'll see you soon. Welcome back, Mindsetters. I hope you had a nice little break. You went and got water like I did because I'm thirsty and my brain needs water to function because lately I haven't been doing that, so my brain's kind of been in and out. So like Peter, it's such a bad thing. But anyway, guys, make sure you keep chatting on the page, keep posting. If you're lost anywhere and need help, let me know so I can get that to Peter. But guys, also out there, help each other out. If you know it, don't keep it to yourself. Help another person out. But for now, I'm actually going to hand over to Peter. Peter, take it away.
Cool. Welcome back, and especially to Langa, who asked us this question on scale. And he said, if I have a scale where of 1 is to 2,500,000, and I measure the distance on a map, and it's 11 centimeters, what is the distance in real life? Now, what I just want to bring to your attention is this, because a lot of students don't understand this concept of 1 is to 2,500,000. And every single year, when I question my grade 11 or my grade 12, and I put that up, hands go up, and the first thing they say is, sir, 1 what? And I say, 1 what? And they say, 1 what? 1 centimeter, 1 millimeter, or 1 kilometer? Well, you know what? It doesn't matter. You can decide what it's going to be as long as the units are the same on each side. So you could actually say 1 millimeter represents 2,500,000 millimeters in real life. Or 1 centimeter on the map represents 2,500,000 centimeters in real life. Or 1 meter on the map, if we had a very big map, represents 2,500,000 meters in real life. Or 1 length of my arm from my shoulder to my elbow, one of these little funny lengths represents 2,500,000 of these 2 lengths in real life. You could even go as far as saying that 1 length of my tongue represents 2,500,000 lengths of my tongue in real life. Any unit, as long as the units are the same. So coming back to Langa's question, and we were answering it just before the break, 11 centimeters, so on map I have 1 is to 2,500,000. So in 11 centimeters on the map, how did I get that 1 to being 11? I multiplied by 11. So I'm going to multiply this side by 11, and I'll end up with an answer of 27,500,000 centimeters. Notice my units are the same, both centimeters. Okay? Now, normally, Langa, the question would be, give your answer in kilometers. All right? They wouldn't really want to know what's the length in real life in centimeters. They'd want to know it in kilometers. So let's have a look at this. How am I going to change that to kilometers? Well, there are 27,500,000 centimeters. How do I change centimeters to meters? I divide by 100. Meters to kilometers by 1,000. So I'm going to take this 27,500,000, divide it by 100,000, and when I do that, I'm going to land up with an answer of 275 kilometers. So 11 centimeters on my map represents 275 kilometers in real life. Okay, I really hope that's answered your question. All right. Any others out there? And Langa, thanks for that question, because you asked that question, it was a great question to ask. I think we'll be giving him one of these fantastic Mathslit question paper books.
I think so. Sounds like a plan.
Great. Any other questions?
So far, I think that was about it. Wait, once actually loaded up on my page. Danielle Douglas Walmsley.
Right.
I hope I got that right. Let's say a model of a house is at the scale of 1:20. If the model of the house is 600 centimeters, how long will the actual house be?
Okay,
Well,
give me that scale again. 1:20,
20.
right? And then the
She says if the model of the house is 600 centimeters in length, how long will the actual house be?
Okay, great. Very similar to the previous question we had, which was on the scale on a map. Now, scale for a map and the scale for a diagram or a plan works exactly the same way. Danielle, is it Danielle?
Yes,
Okay.
Danielle.
So Danielle, thanks for the question. Let's have a look at it quickly. So what we're saying now is this, that we have 1:20. First of all, we have to determine, is it the map or real life? So we're going to say the map to real life. So we've got a map, or in this case, a scale diagram. But a scale diagram is still a map of the house, as it were, okay? Or the scale diagram, doesn't matter what you want to call it, to real life. And that's important to determine straight away what is on the map or the scale diagram and what is in real life. Now, this 600 centimeters was on the actual little map that they had, hey, the little scale drawing. So how did I get the 1 to be 600? And it's 600 centimeters. I multiplied the 1 by 600 centimeters. And remember, what I do to one side, I do to the other. So with my calculator, I'm just going to say, right, 600 centimeters multiplied by 20, because in real life, it's going to be 20 times bigger. So we're multiplying it by 20. And we get an answer then of 12,000. So I've got 12,000 centimeters. Okay, 12,000 centimeters in real life. Now, normally, when they're asking you the size of a house, they might say, well, what's it in meters? They wouldn't really ask you how long's a house in kilometers. Whoa, unless you live in one huge house. But that's not going to happen. So they'll probably say to you, how long is the house in meters? How do we change centimeters to meters? We're going to divide by 100, because there are 100 centimeters in a meter. So my house is, in real life, is going to be 120 meters long. Oh, that's a long house, I kid you not. All right, Danielle, I hope that answered your question, and thanks for tuning in, and thanks for asking. And one of those books are on your way to you. Cool. Another question time.
I think that's about it for now. Haven't seen anything else so far, so yeah.
Okay, there was one other question that our producer came in and asked, and that was to do with the area of a garden.
Yes,
okay.
yes.
Should we do that now, or should we wait for it to, will she forward it to us?
I think we can probably tackle one now.
Should we tackle one now? All right, let's tackle one. It means I'm going to have to make it up. I don't know who you are out there. Maybe our producer can just write to you. John, if you're out there, just write to us and let us know who asked this question. But basically it was, what happens if I get given the area of a garden and it's got a little swimming pool in it, or a little sand pit and a little pond? How can we calculate the area of the grass around the sand pit and the pond? Something along those lines. Okay, so let's have a look at it. Let's say I've got a sand pit, and my sand pit is going to be in the corner of my little garden, right? And then I also got a little fish pond in my garden as well. Not too close to the sand, otherwise the fish will be eating sand, and then we've got to bury them under the sand, which is just a horrible thing to do. So there's our fish pond, there's our sand pit, and all this area outside the sand pit and the pond, we want to grass. And we want to say how much grassed area is there going to be. Before we do that, though, we've got to have a few dimensions. So I'm going to make up some as we go along. And I'm going to say this. Right, let's pretend, and I'm going to use a different color here. Let's pretend our garden is 10 meters long. Okay? And we're going to pretend that it is 5 meters wide. Okay? I am going to pretend that this distance over here is going to be 3 meters. Am I? Yeah, let's make this one 3 meters. And I'm going to pretend that this horizontal line is 5 meters long. Okay, sure. In fact, let's make this 1.5 meters, and let's make this 2.5 meters. Okay. I'm going to say that the radius of my pond is going to be, let's make it a little r for radius, is going to be 1,2 meters. Right. So now, there's our whole garden. We've got a little pond, 1,2 meters in radius. We've got a weird kind of looking triangular sand pit where we know the length from this point or the corner down to that point is 1.5 meters. We know this line, that part of our sand pit is 2.5. We're not too sure on that length, so we're going to have to think about it. And we know that this is 5 meters long, 10 meters, 10 meters long and 5 meters wide. Okay, now gentlemen and ladies, the concept is quite basic. What we're going to have to do is we're going to have to find the area of the entire garden area. Once we've done that, we're going to find the area of the pond, find the area of our little sand pit. Once we've found the area of the pond and the sand pit, we can say, you know what, the whole area minus the pond, minus the sand pit, will give me the leftover area, which I'm going to plant some grass in. All right, so let's have a look at that question. So first things first then, let's find the area of the entire garden. So the whole area of the garden is going to be area equals length times breadth, because we're dealing with a rectangle. The length is 10 meters, and my breadth would be 5 meters. So the whole area is 50 meters squared. And remember, we're dealing with area, and area has to have its units in squared. Okay, understand the concept? Now what we're doing is we're finding the area of that pond. And the area of a circle is pi times r squared. And you would be given that formula. Right, so the area of the pond, let's go, area is going to be pi times r squared. And they would tell you to use 3,14 multiplied by my radius, which we told is 1,2, and we're going to square that. So with the use of our calculator, we say 3.14 multiplied by 1.2 squared equals, and we're going to have an answer of 4,5216. Will you remember that for me, Ty? I won't remember it. Okay. 4,5216. Let's go. 4,5126. Thanks for the help.
216.
Right, 216.
Yes.
Oh my goodness. So it's 216. All right. So 5,216. Cool. So that's the area of the little pond. Now let's find the area of my little triangle. And the area of a triangle is half times the base times the height. Okay. So it's going to be a half multiplied by the base, and let's use that 1.5, so it's times 1.5 times the height. Now I want to show you something here. We know that the base is over here and the height is this line, but we don't know this line's length at all. So is it possible to find it? And yes, it would be by means of Pythagoras. And normally in this question then what would happen is we would say use the following formula: a squared equals b squared plus c squared. And Pythagoras, let's go through it quickly. Pythagoras, if we made this a little a, and that a little b, and that a little c, we'd say Pythagoras, a squared is equal to b squared plus c squared. And it would say, with the use of Pythagoras' theorem. So let's use it. So we are going to say, you know what? We know this length here is 2.5. That length is 1.5. How do we find this other length? And remember, it's a short side, because the long side is always opposite the 90 degrees. So by means of Pythagoras now, I'm going to say I've got 2.5 squared minus 1.5 squared. And that's going to give me my side squared that I'm looking for. So with my calculator again, we're going to say, all right, so I've got 2.5 squared minus 1.5 squared equals, and I get an answer of 4. So my answer is 4. And 4 is equal to my side squared. So what's the side going to be? Well, if the square of something is 4, how do we get the square root? We square root it, obviously. So if I've got 4, what's the square root of 4? It's going to be 2. So the length of the side now we know is 2. Sure. Now we can substitute that into our area formula for a triangle. And so what we're going to say is this. Now we know we've got a half, or 0.5, multiplied by 1.5, multiply that by 2 equals, and my answer is 1.5. So the area here is going to be 1.5 meters squared. Okay. So let's look at all the areas we found. We have found the area of that whole triangular thing. And we worked out the area of the whole triangle is 50 squared meters. We worked out the area of my pond is 4,5216 meters squared. And we worked out the area of my sand pit is 1,5 meters squared. Now, what's the area of all the space that's left over once I've not used my sand pit or my pond? It's going to be simple, isn't it? It's going to be 50 minus that figure minus that figure. Let's have a look at it straight away. We're going to say, right, 50 minus 4.5216 minus 1.5, and it's going to equal 43,97. And if I said to you round to the nearest whole number, you would make it 44 squared meters. Right. I hope that's answered the question to the viewer who asked it.
Yes, her name is Karabo.
Karabo. Karabo,
Yes.
thanks for that question. I hope I gave you a nice type of question to simulate what you were actually trying to ask us. So thanks, Karabo. And again, a book's on its way for you. All right.
Alrighty.
And before we carry on with any more, I believe we're going to take another quick ad break.
Yes.
Let's do that.
All right. So guys, you know the drill. Make sure you stick around. Do not go anywhere unless you really have to go to the bathroom, which you have approximately this ad break to do it in. But guys, we'll see you soon. Welcome back, Mindsetters. I hope you had a nice little break. You went and did whatever you needed to do so you can focus and pay attention in this last segment. So you guys, keep sending in those questions. Keep sending up those posts. Guys, and don't forget to help each other out. Mr. Peter, I actually got a question here from Siche. She wanted to find out, okay, a deck of cards consists of 6 cards. The Jack, the Queen, and King of Spades, and clubs. Joe draws 2 cards without replacement. Question is, how do we write the following probabilities as percentages? A, of getting 2 kings. B, of getting a king of spades and any other spade. And then C, getting 2 spades.
All right, well, welcome back, folk, and thanks, Sihle, for that question. So we're going on to a question about probability, okay? And you know what? Probability is normally answered so badly in the matric exam, so I'm glad you're asking this. So just to recap that question is this. So what we're saying is this. So we've got 6 cards, any 6, right? And those 6 cards happen to be the Jack, the Queen, and the King of Spades. And remember, spades is drawn like that. It looks like a spade. All right, so there they are. Then I've got a Jack, a Queen, and a King of clubs, all right? And that looks like a little clover leaf, the clubs. And I'm sure you know packs of cards. If you don't know a pack of cards, guys, do yourself a favor, hey? Go and play cards with some buddies. Just get used to what's in the cards. In fact, one of the things I do with my grade 10 classes is we have a day where we play cards. So they come into my class and we play all kinds of games with cards, just so they can get used to what cards, a pack of cards consists of. But for this question, we don't have a whole pack. We just got the 6, and there they are. Now, the first thing is, what's the probability of drawing 2 kings? But the important thing about the question is this, that once we've taken a card out, we're not putting it back in. So we are actually saying, I want a king and I want a king. Now, with all 6 cards, here they are. All 6 of these cards. Right. Firstly, how many cards are there? There are 6 cards. So I know I've got something over 6. How many kings do I have? I've got 2 kings. Do you agree? So we've got 2 over 6. The word and in probability means times. Remember, if I had to say, if the question was, what's the probability of drawing a king or a king? The word or would mean plus. But we're dealing with and. And as soon as we deal with and, we're talking about times. Now, once I've taken out a king, how many cards are left? There are 5. Agreed? There were 6. I've taken one out. So I've got 5 cards left, and one of them happened to be a king. Now, I've got a simple mathematical calculation where I've got 2 over 6 times 1 over 5. And let's do this on our calculator. I love using my calculator for these things. And the reason I enjoy using my calculator for these things is because the calculator is actually going to simplify my answer for me. If I did this in my head, I'd get 2 over 30. My calculator is going to say, yeah, 2 over 30 is right, but simplified, it's 1 over 15. So my answer now is going to be 1 over 15. So that's the probability that I have of drawing 2 kings out of that pack. Okay? Now, let's look at the next one. The next question says, what's the probability of getting the king of spades and any other spade? So I want the king of spades and another spade. Right. How many kings of spades are there? There's only 1. And there are a total of 6 cards. And means times. Now let's just have a look at our card. Once I take the king of spades out, how many spades do I have left? I've got 2 left. I've got a jack and I've got the queen. So I've got 2 left. Out of how many? Well, I took the king out, so I've only got 5 cards left. So my answer again is going to be, with my use of my calculator, 2 over 6. Now I've got 1 over 6 multiplied by 2, multiplied by 2 over 5. And my answer again, 1 over 15. So once again, the probability is going to be 1 over 15. So the likelihood of getting 2 kings is 1 over 15. The likelihood of getting a particular king and any other spade in that family, or any other card in that same family, or any other spade, is also going to be 1 over 15. Then it says, what's the probability of getting 2 spades? Okay, any 2 spades. So I want a spade and I want a spade. Now, how many spades are there? There are 3. There's the jack, the queen, and the king of spades. So there are 3, right? And a total of 6 cards. So I've got 3 over 6. The word and means times. Now, once I've taken one of the spades out, I've got 5 cards left. And how many spades do I have left? I've got 2 left. So I've got 3 over 6 times 2 over 5. So again, with our calculator, we are going to say, right, I've got 3 over 6 multiplied by 2 over 5 equals, and my answer, 1 over 5. So I've got a final answer of 1 over 5. Right. See, Claire, I hope that answered your question. Thanks for it. And there's one of these wonderful books coming your way. All right, thanks. Do we have any other questions?
I think that's about it for now.
That's about it for now. All right, so let's go back to the questions which we had set or were going through at the beginning of the program. Now let's have a look at our next one. An aquarium is a place where collections of fish and other aquatic animals are displayed. The fish are kept in open rectangular glass tanks, and a water pump is used to circulate and refresh the water in the tanks. An open top fish tank has the following dimensions. It has a length of 2,5 meters, it has a breadth of 2 meters, and it has a height of 1,5 meters. Right. Now, what's our first question? Determine the volume of the fish tank in kiloliters if 1 meter cubed is 1 kiloliter and where volume is equal to length times breadth times height. So they've asked us one question. But although they've asked us one question, they've given us 2 bits of information or 2 types of formula that we are going to have to use. And guys, we're going to have to use both of them. We are going to have to use the fact that 1 meter cubed is equal to 1 kiloliter. We are going to have to use the fact that volume is equal to length times breadth times height. Because if we don't use it, what we're actually saying is, oh, this examiner has lost his mind totally, doesn't know what he's doing, he's just giving us random bits of facts that we don't need. Rubbish. The examiner is never wrong. All right? Or they shouldn't be anyway. And so, if they've given you those facts, you're going to have to use them. And right in the beginning of this program, I said the following. When my mom put food in front of me, she said, oi, you eat it all, boy. You're not getting off this table until you've eaten your food. And in the same way, what I'm saying to you is this, oi, you're not getting off that question until you've used all those formulas that are in front of you, all the facts that are in front of you. Okay? So let's use it. First thing then, what is the volume of the tank? So we are going to say, okay, volume is equal to length. My length was 2,5 meters. My breadth was 2 meters. And the height of my fish tank was 1,5 meters. So times 1,5 meters. Now we're going to get our answer in meters. And we start off and we say, right, we got 2.5. Multiplying it by 2, multiplying it by 1.5, and we get an answer then of 7,5. 7,5 what? 7,5 meters cubed. Why cubed? Because I'm dealing in area. Okay, so we've used the one formula, and in using the one formula we found the volume of the tank. But now we're told that 1 meter cubed is equal to 1 kiloliter. So how many kiloliters of water do I need? Well, that's simple. 1 is the same as 1. So if I just multiply this by 1, I'm going to get an answer of 7,5 kiloliters. So that's how many kiloliters of water I'm going to need. What's a kiloliter? Kiloliters, 1,000 liters. So if they went on to say, well, how many liters is that? You would have to say 7,5 times 1,000 liters, which would give us 7,500. Right, let's move on. Next question. And we've only got about 2 minutes, so we're going to try and do this as quickly as we can. Determine the total surface area in meters squared of glass used for the open top fish tank. We're told that the surface area is equal to length times breadth plus twice the length times the height plus twice the height times the breadth. All right, guys, lovely question, and it's nice because they're actually giving us the entire formula. Right, so how do we calculate the whole area or the amount of glass I need? We need the glass at the bottom. Do you agree? Now, the glass at the bottom is the length times the breadth, and that's where we get that from. Why not twice? Well, we're not putting glass on top. We just got the glass at the bottom. Okay? We're going to need twice the length times the height. Why do we need that? Well, the length times the height is this bit of glass facing here in front and the bit at the back from that side. So it's the glass in the front, the glass in the back. Now we've got to calculate the area of the glass from the sides. And the sides you can see is going to be your height times your breadth. So it's that and that glass over there. And so all we're going to do is we're going to substitute those values. And we're going to say, right, let's do it very quickly. Okay? And we've only got 20 seconds. So you know what? I'm not even going to be able to do that for you. But just to say, we just substitute the values in there. Guys, it's been great spending Saturday afternoon with you. We always run out of time. But I'm sure I'll see you again on Thursday night.
All right. So guys, make sure you guys just keep chatting to each other, because this page is for you guys and this revision is for you. So you guys, the more you talk about it, the more you share it with other people, the better it is, because the whole point is that this is just supposed to be like a whole giant melting pot of information for you guys. So keep posting, and I will be giving more of these out, so make sure. But guys, you know what? I am going to sign off and say see you next time, and take care.